So I'm going to do section 7.3 number 3, and this is the problem. It's a trig substitution problem. Okay, so first what we do is we recognize that this is a secant. So let x equal 2 secant theta, then we take the derivative of that, dx equals 2 secant theta tan theta. And then we also know that this is going to equal 2 tan theta. Then after we do that, we just basically put all of these into the problem, like plug them in basically. So then the top, that's 2 tan, and then the x is 2 secant, and the dx is 2 secant tan d theta. Okay, so then after we have that, secants, the secants cancel, and then we just have the integral of 2 tan squared theta d theta. And then here we just use an identity for tan squared. So then we leave the 2 on the outside, and with the identity, it's secant squared theta minus 1 d theta. And then that's it's pretty simple just to take the integral of, right? And so what we get, so the integral of secant squared is just tan. So then that's tan theta, and the integral of 1 is just theta. That's theta, so that's plus c. And then we have to put this back into like X format, I think it's called. So we do the triangle, and so we have x here, 2 here, and then we find out that this is here. And so then we find a tangent, so that's opposite over adjacent. So opposite over adjacent, opposite is square root of x squared minus 4, and then adjacent is over 2. And then to find theta, to find what theta is, it's just the inverse, so it's the inverse of secant. So the inverse of secant should be x over 2. So then your final answer is 2 parentheses square root of x squared minus 4 over 2 minus the inverse of secant x over 2 plus c.